As though we only had the first page of 3.2 saved in videos. So I'm going to make a short video for the rest of section 3.2. But I'm going to start with a reminder of the first page where we talked about end behavior. And we had all of this vegetable soup going on in here, or letter soup, or letter salad, or word salad, whatever you want to call it. A whole bunch of stuff going on in here. And we did simplify it down to a couple of things. If my exponent is even, my beginning and end behavior are going to be the same. If the leading coefficient is even, I approach as I go to negative infinity, this goes to infinity. As I go to positive infinity, this goes to infinity. And of course, here, if my leading coefficient is negative, it flips it like negative 3x to the fourth. As I go to negative infinity, this goes to negative infinity. As I go to positive, this goes to positive. Okay. And we also talked about when it's odd, how they go opposites. If the leading coefficient is positive, something like that. If the leading coefficient is negative, they get flipped. So just a quick review of what was going on in that beginning. We jumped down and we hit the first problem, and we saw the exponent was odd. So we know its end behavior is going to go with the odd degree, x to the fifth, and it's a positive leading coefficient, matches this guy up here. If I had multiplied all these together, I would basically end up with negative 2x to the fourth. So the degree is 4. So they go the same direction. The leading coefficient was negative, so it got flipped. So after that, we now hit section 3.2. And let's see what we have going on here. So this first problem, number 3, talks about identifying zeros and the multiplicity. So let's take a look at this. The zeros, we've given them quite a few names. Roots was another name. We've actually called them x-intercepts, another name, and so forth and so forth. They all mean the same idea, and they're a big help in graphing because it tells me where I cross the x-axis. So in order to determine these zeros, these roots, these x-intercepts, I want to set my equation equal to 0. So 0 equals x cubed minus 5x squared minus 16x plus 80. And one of the methods for factoring that I learned was if I have 4 terms, maybe this thing called grouping will work. And I'm just going to take a look at it. I'm going to group these two together and say, what's common? X squared. What am I left with? X minus 5. And as long as I can do grouping over here and I'm left with x minus 5 again, I'm happy. And after taking a look at it, if I group these two terms and I pull out a negative 16, it's all looking pretty good. Pull this term and this term have an x minus 5 in common. I'm left with x squared minus 16. I can factor that into the sum and the difference, and I get answers of 5, negative 4, and 4. So I know this graph, something's happening at negative 4, boom, something's happening at positive 4, and something's happening at positive 5. And my guesses are that this is odd, positive. It's going to start down here. It's going to end up there. So something's going to happen where it's going to go up, maybe down, and back up again. Thinking something along, and I'd have to plug in some more points to see how this actually works. But I have a head start on what this graph is going to look like because I took a look at the zeros and we also talked about multiplicity. A little more going on with multiplicity. I'm going to look at this guy. And this for number 4, what numbers make all of this 0? And the forgotten one is this guy right here. If I made him a 0, boom, this whole thing becomes a 0. So when I start looking at roots, the first root is 0, and it's just an x, so it has a multiplicity of just 1. So that means when I'm graphing at 0, I have an x-intercept, and it's crossing because the multiplicity is only 1. My next root is 1. It's squared, so it has a multiplicity of 2. So that means this guy is touching. Now, however it goes, before that and after that, but it's going to be touching. It's going to come down and touch and go up, or it's going to go up and touch and come down. My last one is -3. It has a multiplicity of 3. This was odd, so it crossed. This is odd, so it crossed. This was even, so it touches. So at -3, I have another 0, and it's in fact going to cross. So I have an idea of what's going on with that graph. Coming down to this one. What effect do multiplicities have on the 0 roots? So I look here, and again, this is just what we've been talking about. Something happens at 0. It's a 1, so it crosses. Something happens at 1. It's a 1, so it crosses. Something happened at -3. That's also to the first power. It crossed. X to the first crosses. At 1, it comes down and touches because that is an even number. And as you can see, -3, it crosses as well. One more example. At 0, it crosses. At 1, it crosses. At -3, it touches. 3 pretty good examples, hopefully, that'll help you understand how this whole touching and crossing thing tends to happen. I'd asked if there's any questions, but I don't have a class in front of me to ask questions. Okay. So again, if the 0 has odd multiplicity, it crosses. If the 0 has even multiplicity, it will in fact touch. So if I'm looking at this guy, my first root is 0. And I know that because it has a multiplicity of 2, that this guy is going to cross. Excuse me, touch. It's even, it touches. First power. Root is -4. It's to the first power. This guy crosses. My next root is 7. Its multiplicity is 3. So in the graphing of this function, we would have one spot where it touches. We would have cross and a cross. Multiplicity is 6. That means this is, if I multiplied everything together, I'd have to the 6th power. So this function would actually start -3 x to the 6, blah, 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 had I multiplied everything together. So I now know even, together, but since it's a -3, it's going to start down here. It's going to end here. At -4, I'm crossing, so I'm going to be going something like that. At 0, I'm touching. And all the way out here at 7, I'm going to sort of go back up, and there I go. Gives me a general idea of what this graph is going to look like. Cool, I know, right? Everybody says cool. Okay, so we have this new term coming up here in number 6. It's called turning points. And as you can see in this graph, I'm going up, and all of a sudden I turn and now I come back down. Well, that's what a turning point is going to be. And what we're going to find out is whatever the degree is, in this case, we're going to say n, it has at most n minus 1 turning points. So when I'm looking at this equation x cubed, I know at most it has 2 turning points. So just another piece of terminology that we use called turning points. Okay. Later in calculus, you're going to get another point that's going to hit to here, but instead of coming back down and turning, it turns and goes up. This is actually called an inflection point. So that's something down the road, giving you a little heads up. Okay, so if I want to sketch a polynomial, got all this stuff that can help me out. Okay, use the leading term and behavior. That's something that we just covered, and we should be good with that. Determine the y-intercepts. Okay, that's basically if I said x and y, and I put in 0 for y, what are the y-intercepts or the x-intercepts? Put in 0 for x, I can find the y-intercepts. Kind of basic early on what we talked about. Okay, here we get into, we may have to do some factoring when we let y equal 0 in this first case to get the x-intercept. So what have we learned so far as finding out how to do it? Plot the x and y intercepts. We just talked about end behavior. We've talked, and probably we'll talk again about even and odd functions. And to make it more accurate, as always, plant a couple, or excuse me, not plan them, they're not going to go. Plot a couple of extra points to help you out. Any questions? Okay, good. Good. No students here again to help me. Oh boy, to help me. Oh, let's see what we have going on here. If I had multiplied everything together, right, what would I get? I think I would be getting like x to the fourth. Again, if I come over here and I start looking at my intercepts, you know, my first one is 1, and that has, so my intercepts here has a power of 2, and that means it's going to cross. So I need to keep that in mind. I have an intercept at -3. Its power is 1. Messed this up again, didn't I? Has a power of 2, so it touches. This one crosses because it's odd. And my last intercept is 4, and it has a power of 1, so it's going to cross. So I got some stuff going on there. And again, this is a power of 4. So I got the power. The power is 4. My leading coefficient looks like it would be a positive if I multiplied all this together. So my general shape is going to look something like that. We just talked about turns, and since the total would be a 4th degree, 3 at most, then my crosses and touches. We also talked about x and y intercepts. If I put in 0 for x, you know, what would I get if I put in 0 for x? Well, it looks like I'm going to get -1 squared. If I put in a 0 here, I'd get 3, and there I would get 4. So it looks like it's going to be, I believe, positive 12. And of course, if I put in 0 for what, yeah, I got all these guys, right? These are my 3 intercepts. So let's see what I have. This graph goes 30, -5 to 5, and 70. So it looks like these guys go by 10, and these going across are going by 1. So my first x is 0 on the x, and I'm going to go up. Looks like I'm going to go to the point 0, 12. Well, let's do these first. At 1, it's going to touch. At -3, it's going to cross. And at 4, it's going to cross. Okay. I know my general shape, so I'm going to start up here. I'm going to go down. I'm touching here. So if I'm going down there, I'm going to be going something like that, which means I'm going to be going up like that, which means I'm going to be coming down. So I'm touching and crossing all of this, and it matches my end behavior. And I do have 1.0 positive 12. Let's see what we have here. Excuse me, this 4 is a negative. I went back and checked because I need everything to make sense, and I did actually mess up. If I put a 0 in here, that's -4, causing this to be -12. I'm sure one of you said, well, you messed up, you messed up. I'm like, yeah, I know I messed up. So I got the point 0, -12. So if I wanted to put in more points, I would 1, 2, 3, 4. One of the points I would put in is -1 because that's going to tell me how low to go because that's halfway between these two. And this is 1, 2, 3, 4, yeah, and a half. So if you put it in, it's going to go down somewhere and it's going to come back up and hit this and come down to I don't know how low and then go back up. But as I said, I would put in 2 more points to help me out. Halfway between is -1. Plug -1 into all of those. And this would be 1, 2.5. I'd plug that in to tell me exactly how low I need to go there. And I'd be able to come up with a graph. Number 8. Oh boy, sketch the graph. Let's see what I can do. I know the first power and the second power. If I add them together, this guy is going to have a degree of 3. And it looks like my leading coefficient is going to be a negative. So if this is odd, it would go here and up to here. But because it's negative, I'm going to go there and finish there. Odds are opposite. Because it's a negative, we switched them. Something is happening at +1. Excuse me. Something is happening at -1. I tried to skip a step. So I'm going to come up here and I'm going to call this my 0 or my x-intercept. Has a bunch of names. -1 is the first one. Its degree is 1, which means it's going to cross. My next one is +3. Its degree is 2, so it's going to touch. I can get my y-intercept. If I have y equals negative and I put 0 in for x, like I did up above, I'm going to get -1, boy, -3 cubed. -3 cubes, 3 times 3, going to give me 9. I'm going to get -27. So this ends up being +28. So hopefully that's going to make sense in my graph. And let's see, if I put 0 in for x, I get 1. And oh, that's squared. Excuse me, that's not cubed. That's going to make a big difference, isn't it? Thank goodness for erasers. Negative. This equals -1 times 9 or -9. So yeah, this better come down to -9. And again, this is the good thing about doing all these pieces. It all has to make sense in the end. And if it doesn't, me, screwed up. Going to come down. It's going to hit this point. You notice it's halfway between those. So I know that's as low as it's going to go. It's going to go up and touch and boom, back down again. Putting all those pieces together. Questions? Okay, the last thing that we're going to talk about, and it's brief, it's called the intermediate value theorem. And basically this says if I pick a point and it's positive or negative, if I pick a point and it's positive or negative for my y value, and then I plug in another point and it's the opposite sign, then it has to cross the graph. So this is saying, hey, I want you to show that there is an actual 0 that this guy crosses between -1 and 0. Now, they're not, I don't know why I just did that. I'm just going to darken these because they're not x-intercepts. They're not x-intercepts. And we'll see in a second. If I plug -1 into this, oh boy, what am I going to get? -1, that becomes a positive. -13, that's a negative. So -33 plus 35, it looks like I get -12. Okay. And if I plug in 0, I have 35. So just looking at these 2 points, at -1, I'm way down here at -12. That's a point on my graph. If I plug in 0, I'm all the way up here at 35. That's a point on my graph. And what this intermediate value theorem says is, because this is negative and this is positive, this guy has to cross the graph at least one time. It has at least 1 0. So it's something that is, it's got an official name, the intermediate value theorem, and it's not something that we really use, but it's one of those that you may go, well, yeah, that kind of makes sense. I get it. So sorry for the missing part of 3.2, but now you have it. I hope it helps, and good luck on your next test.